Okay, hi everyone. I wanted to talk really quickly about reference angles. Okay, so what we're going to do here, as we take our trigonometry and we move around the circle here, you have to keep in mind that all of our trig ratios are still dependent on right triangle trigonometry. So in the first quadrant, that's really easy to work with here. So we're going to rotate out. Here's our rotation angle, and that's giving us our different sides here. Now, just for argument's sake, okay, let's say that that we're dealing with sides. Let's say this is 3, 4, and 5. Okay, just for argument's sake here. And so that's going to go along with a specific rotation angle. Okay, now that angle, because it's in the first quadrant, in this case here, theta is going to be acute. Okay, so that little angle right there. Now, I'm going to give this another name as well. I'm going to call it alpha. Okay, and I'm going to define alpha to be the acute angle between, okay, the terminal arm of an angle and the x-axis. Now, always the x-axis. At no point here are you ever going to see me go to the y-axis on this one. So now, as we saw before, what we're going to do here is we're going to reflect this triangle over the y-axis. Now, that's going to come over here. So this side is going to be -3, because now I'm pointing towards the left along the x-axis. The y-coordinate will still be 4 here, and this will be 5. The hypotenuse, because it's based on the Pythagorean theorem, the hypotenuse will always be positive. Now, here's my reference angle. My rotation angle, I should say. Just like before, remember we're using this terminal arm here, okay, to build this rotation angle. But notice that the triangle here is identical to the one I started with previous to it. Now, what that means to me is that the trig ratios for theta should be identical to the trig ratios that I had for this first triangle here. So, to illustrate that, I'm going to throw in that angle, that reference angle right in here for this triangle. And the way we do this is we say that all of the trig ratios for this alpha in this triangle right here will apply to theta. So if we take a look at this, because of the way alpha is situated here, the sine of alpha would be 4 over -3. The cosine of alpha would be -3 over... I'm sorry, I said that wrong. The sine of alpha will be 4 over 5. The cosine of alpha will be -3 over 5, and the tangent will be 4 over -3. Well, what we do is we apply all of those to theta. So the sine of theta here is going to be 4 over 5. The cosine of theta is going to be -3 over 5. And the tangent of theta will be 4 over -3. Okay? And that's why we call that the reference angle, because everything that applies to the alpha here in this quadrant, we're going to say by definition applies to theta. Now, in quadrant 2, okay, the relationship is that theta plus alpha is equal to 180 degrees. So anytime you've got two angles, that we can see two angles here that add up to 180 degrees, we know that it's going to have, that those two angles will share the same sine, cos, and tan. It's just we have to concern ourselves with the signs, okay? Because we're in the second quadrant here, cosine and tangent will both be negative. If we move this down, take the same triangle and flip it down into the third quadrant, okay, again, the hypotenuse is still 5. Now, the opposite side here will be -4. The adjacent side will still be -3. So again, signs have changed, but the ratios, okay, the values, the numeric values are going to stay the same. So this, again, this is the theta that we're analyzing, but this angle here, the reference angle, okay, has basically stayed the same. Okay, it's the same in the previous two triangles. So the sine here of theta, by definition, if you look at the alpha here, is going to be -4 over 5. So that's what we say for theta. Cosine will be, for the alpha here, will be -3 over the hypotenuse 5. So that's what we say applies to theta. And then tangent And because, again, because we're in quadrant 3, okay, I know that tangent is going to be positive. In quadrant 3, and this seems to be a bit of an issue for a number of people here. We're not quite clear on this. The way this works here is my rotation angle is equal to 180 degrees plus the reference angle. Okay, I come out to there, and my reference angle is this little bit between the x-axis and the terminal arm. I'm not going to the y-axis. Please, you got to resist the temptation to do that. Okay, so you need to know this relationship here. And then finally, we're going to take this over into quadrant 4, where that point in this case, okay, or if you want to think of it like this, the triangles, now the x is going to change to positive, the y is still negative, and again the hypotenuse is still 5. Here's the rotation angle, and there's the reference angle. It's the same angle, where it's the same triangle in every quadrant. We're just moving it around, so that has stayed there. How do I relate that back to the theta here, the rotation angle? Well, in this case here, the rotation angle is going to be 360 degrees minus alpha. And then just to talk really quickly about the trig ratios here, the sine of theta is going to be negative 4/5, okay, negative 4 over 5. Again, those are what we're getting from alpha there. Cosine is going to be 3 over 5. And tangent will be negative 4 over 3. Again, very consistent with the cast rule that we saw before. But what I want you to get out of this is the relationships between theta and alpha in all of the 4 quadrants. Up here in the first one, I didn't say it explicitly, but so here it is right now. They're the same. In quadrant 2, okay, if you want to know how those two relate here, it's the sum of the two, the theta and the alpha, is 180. In quadrant 3, okay, quadrant 3, really it ends up being the difference between them, but it's 180 plus alpha is equal to theta. And in quadrant 4, it's 360 minus alpha is equal to theta.